Welcome back to the Subscribe blog here on Channel 9, and today I'm talking about queues, getting started with queues. So I'm going to guide you through Visual Studio in the form of a screencast and show you how to create a new queue. I'm going to go and walk through some of the options that we have, and then we'll send messages to a queue, receive a message or messages from a queue, and also walk through the various options that we have, how you can handle messages, how you need to handle messages actually. After you've received them, we have a model called peak lock, where you can first get a message and start handling it, and then you go and complete it. So I'm going to go through a number of those options with you in Visual Studio and along the lines of code. To get started with queues, I'm going to create a project in Visual Studio. I'm in Visual Studio 2012, and I have the Windows Azure SDK installed. As I showed you the tooling for Visual Studio in a previous episode here on the Getting Started series on my blog. So I'm going to go and create a project. I'm going to make it fairly boring. I'm going to call this console application. I'm not even going to change the default name. And into that console application, we're going to add a reference to the service bus assembly. We're going to do that over NuGet. While we do this, I'm going to keep this open here. The application config file, I'm going to go into NuGet. I'm going to look for Windows Azure. And here is the service bus assembly. Let's go and put this in. Accept. And what you'll notice is as soon as this is done, and I go and close this, it will ask me for some updates it made to the application.config file. It will also do that through the web.config file. And you'll see some things that we add here. Most of those things are for the relay. Two here in these sections are for messaging, and also with that for queues. It's the net messaging transport. That's a low-level binding element that is for transport options. And there's the net messaging binding that's here. That's kind of bundling a number of options together. But you can go and use WCF configuration, the Windows Communication Foundation configuration, to go and put those things together. So this is all for the Windows Communication Foundation. And you can use the net messaging binding against Service Bus, both server and service, in a very similar way to how you can use MSMQ. So if you have existing applications that depend on MSMQ but use and do that through the Windows Communication Foundation, you can largely replace those links by using Service Bus. There's another setting here, Microsoft Service Bus connection string. That's an important one because that's being picked up automatically by the API, as I will show you in a few moments. I have configured with the Visual Studio tooling that I showed you in the previous episode, or one of the previous episodes. I have a namespace here, so here's the connection string. I'm going to mark this all and copy it all, and then I can go and replace this value here, and with that have my configuration information for talking to this Service Bus namespace kind of embedded in my application, and the API will go and pick this up. Instead of using the namespace manager, which I've been using in a previous episode, instead I'm going to go and create the queue through the tooling here, and we'll discuss some of the options. First, I can give it a name. The name can be plain, but the name can also be structured. So I could go and make ERP orders submit. And with that have, the ERP system has all of its substructure sitting here, all this in the order subsystem has all of its resources, its queues sitting in that branch. So you can basically create it as a structured thing. I'm going to keep it simple. I'm going to just call it test. Here you can go and add some a description. So you know what this is for, and you can also find this through the management API. And then there's a number of features which you can turn on in the through this dialog. It's not all the features that we have, but the most important ones. So let's go through them one by one. Default message time to live is the time to live we set on the message if you don't supply one. The time to live is a feature that allows us to, where you allow us to delete the message if it gets older than a certain amount of time. The default is that there's no limit. The message gets held in the system effectively infinitely. If you want to set this to, let's say, 20 minutes, you set this here to 1200 seconds by unchecking the use default box. And then we will stamp all the messages that don't have time to live explicitly set with 1200 seconds, equating to 20 minutes. The reason why you would want to use that feature is because data you submit into the system is not necessarily valid if it sits in a queue forever, but or no longer relevant. And if you have no longer relevant and stale data sitting in the system, that typically hurts more than it helps. If you have jobs that you want to submit from a client, and the client doesn't set the time to live, then you can also figure out from the client side whether the messages have been processed by checking this box and enabling dead lettering on message expiration. Every queue has a companion queue or sub queue called the dead letter queue. And instead of deleting the messages when they expire, we will move them to this dead letter queue, which is functioning like a normal queue. You can receive from it. You can't send to it, but you can receive from it just with a normal protocol. It's also available through HTTP. And then you can go and pull messages out and see which messages have not been picked up by the intended receiver. So they give you a feedback mechanism effectively into the sender. So the sender can go and send messages out, and it can sit there and wait for which messages have expired or have been rejected for other reasons. Explicit dead lettering, or because they have been causing too many deliveries. Let's skip these two and then talk about this one quickly because it's related. This is the maximum delivery count. If we deliver messages more than 10 times, by default, I can set this to 5. Then we will also go and take that message and move it into the dead letter queue. Delivery, each time we deliver the message means that your application is using the peak lock receive mode as it's receiving messages and is not completing a received message. There might be many reasons for this. One might be a crash, or another one that you explicitly call abandon. And if you abandon a message, which means you're effectively rejecting the receipt, if that happens 5 times, 10 times, depending on how you do this, then we also move that message into the dead letter queue and the sender can know. The automatic maximum delivery count is meant for poison message handling. If a message gets delivered and it keeps crashing your application, for instance, and so your application never gets to the point where the call is complete, then we automatically do that for you. We automatically move that message into the dead letter queue. You can do that explicitly in your code by using the dead letter gesture. The maximum queue size is a setting that is normally, the default is 1 gigabyte. You can dial this up to 5 gigabytes. The recommendation is that you leave that at its default unless you have so much traffic that you actually will need 5 gigabytes. Use maximum size is a setting that you can set that you always want to have the maximum size that's available in the system. The duplicate detection history time window here interacts with the requires duplicate detection setting that's here. And what that does is it maintains a bucket of message IDs over a sliding window of 600 seconds now. And we remember all the message IDs that we've seen during that time window, and we will reject all subsequent messages with the same message ID. So if you have a process and the process might crash, but the process is able to yield similar repeatable results and also is able to yield repeatable message IDs, then with that you have a fairly simple way of creating an item on a queue. If you need that for transactional behavior, I will have a whiteboard talk about transactions sometimes in the near future, probably early in the next year, and we'll talk about that there in detail. The lock duration also depends on your receive mode, and that's if you have peep clock enabled and you're first peeking messages and then completing them. In that case, you have 60 seconds to do so, and you can go and dial this up to a longer time period, up to I believe 4 minutes, as we have it today, as we have it now, and you can actually go and extend this up to by repeatedly extending the lock, and that's something that the API, the .NET API, will do automatically for you as long as you're holding onto that lock and you're healthy. We're going to go and extend that lock for you. So that's the lock duration. Mostly matters today for HTTP clients because the .NET API kind of takes that away from you. So with all these settings, let's go and turn that dupe detection on. I will go and save this. Oh yes, so 2 options I forgot, should mention those. Enable batching is something that's also turned on by default. It allows you to send multiple messages in a single batch. That's a transactional operation, which means you send 5 messages. Either you send them all or you send none of them. And then enforced message ordering is a forward-looking option because we will eventually create scale-out topics and scale-out queues, which will allow you to have more than 2,000 subscribers very transparently. You'll be able to make magnitudes more than this. However, we need to relax our message ordering guarantees to do that. And so if you want to opt into the super scale features, then you will have to uncheck this. And that's something we already have in the system as a policy setting, so that once we turn that feature on in the back end, we already have the matching policy things for it. So I'm going to save this. This is going to create the queue. This happened fairly quickly. The data center that I'm using here is in Amsterdam. I'm sitting in Germany. And actually physically about 200 kilometers or 140 miles away from that data center. So that's fairly quick. Now I have a queue, and I also have the setting to interact with that queue and to reach the namespace and have my accounts. So I can go and create a new queue client with the queue client API. The queue client, well, it's not available now. It's available now, so it's adding my service bus messaging relationship here. I'm using a little tool called ReSharper. That's a plugin to Visual Studio that just helped me with that. There's a number of other tools of similar shape and quality. For instance, CodeRush, that's also capable of helping you coding faster. I love both companies, but I'm using ReSharper here right now. So I'm creating a queue client for the queue test. You'll notice that I haven't used any connection string or not using the messaging factory. There's a messaging factory for people who have been using the Service Bus API for longer. And there's an explicit messaging factory you can go create. I'm not doing that here. I'm just creating a queue client, and the messaging factory is being made under the covers. And here I can go and control the receive mode. The receive mode by default is peak lock, and the other one is receive and delete. Receive and delete is a faster mode, but if you take a message out of the broker, that message is immediately being deleted. And then if you lose it on the way, then there's no way to get that message back. So the safer mode is peak lock, but peak lock also means that you will have to go and explicitly complete that message when you have received it. So there's my queue client. We're going to do 2 simple operations here. We're going to go and send a message and receive a message straight away. So I'm going to go and on the queue client, I'm going to say send. There are obviously also asynchronous methods for sending, begin send and end send. We're going to go and inspect those in a moment. So I'm going to go and say new brokered message. So I'm going to send the brokered message. Here, as you can see, you can pass in an object, and that object goes into the body of the message. The message is a set of properties plus a body, and you can go and take a serializable object. You can also bring on your own serializer. So if you want the body to be, let's say, JSON text, you can also do that. And if you just supply this by default, we're going to use the net data contract serializer with the .NET binary format. So that's going to be .NET to .NET only. If you want to have something that's highly interoperable, if you also want to pull data out of the message out of the queue using the HTTP protocol, you can create and set a stream and put any arbitrary content in there, and then basically just use the content type property to inform the receiver what that was. I'm not going to supply a body here at all. And you can set here the system properties that are provided. You can set those directly. So I'm going to set the time to live to a time span here of, let's say, 5 minutes. And there's a number of other settings that I can have. So for instance, I could go and set the something funky. The scheduled enqueue time to UTC, I could set that, and with that, schedule the message to only show up in the queue at a particular point in time. And that's what we call scheduled messages. That's an advanced feature of queues, but you can effectively use with that the queue as a timer. But we're going to put some data in here. I'm going to set the properties. The properties are taking a dictionary, so I can go and simply initialize it like this. So I'm going to have a property that I call reading. So you can go and set arbitrary properties here. And I'm going to put in a hello. So with that, I have a brokered message that I'm sending, and now I'm going to go and receive it. So I'm going to go and say, the brokered message, please be qc.receive. Setting no parameters, which means in this case, it's using the default and it's waiting forever. You can also go and set this particular time span. What this receive does is what receive with a time span does, it sets a time that the server waits for a message for you and then returns to you. This has nothing to do with long polling or any of those things that you might be familiar with from interacting with a queue over HTTP. We're building a bidirectional connection, and there's simply a gesture that says receive to the broker, and here's a timeout for how long the broker is going to wait. And this is independent of us maintaining the connection to the server. So you don't need to go and deal with that. We're dealing with maintaining that connection and the necessary pings, etc., all under the cover. So you can set this to this, which means wait indefinitely for the next message, or you can set this to a time span. And typically we'll only set this to a time span if you are waiting for a message on a deadline, and we'll give up in that case. If the time span gets exceeded that you set, so let's say we only want to wait for a minute for a message, and then the timeout expires, you will get a null result in the message here, or you get a null result in the message here, sorry. So now we're getting a message, and I can go and inspect that message. I can write to it. So I'm going to go and write this to the console, write line, the message that we got, because I already got to have an inkling what that's going to be. And it's going to have greeting in it. And I'm going to go and print out the greeting, and if all goes well, it will go and print the message that we sent. There we go. It says hello plus some funky German text. Drücken Sie eine beliebige Taste. Press a arbitrary key. So please press an arbitrary key. I'm doing that, and that's it. So with that, we created a simple queue client with a default messaging factory using the peak lock mode. Now, but I did something wrong here, because it's very easy to do. That message will now show up again in the queue. And why will it do this? Active message count now is 0. But in 60 seconds, there it is again. That message is now showing up in the queue again because I made a mistake. And that mistake is I need to go and complete that message. I need to say, hey, that message is, we're done with that message now. And so active message count is now 1. So now we got that message out. The active message count now is going to be 1 again. Because, well, we sent a new message into the queue. So typically what you will do in your application is you're going to have a receive loop. And that receive loop is going to spin until no messages are left. That's one way, or it will spin effectively infinitely and just pull work off that queue and then dispatch that into your application. That's taking that a little bit too far for the moment, because we're going to discuss asynchronous usage of queues and also of topics. I will discuss that separately. We're going to stick with the synchronous APIs now. While I should say a word of caution, I would not recommend you that you use the synchronous APIs, receive and send, in a server-side production setting, but always use the asynchronous methods. But I'm going to talk about that. So now I commented this out. I fetched that one message that was sitting there out of the queue and completed it. And now we have the world is back in balance. If I go into the settings here and go and refresh it, you're going to see the active message count is now 0, and it's going to stay 0 because we have completed the message. So instead of going into the async path and showing you how to do all those things asynchronously, let's go and talk about some of the options that I have on that message. On the message itself, I can go and complete it. I can also go and dead letter it. So instead of completing, I could dead letter it, and I can also give a reason for dead lettering the message. So there's a dead letter reason, foo, or let's say validation. And then I can say validation of inputs failed. And so the nice thing is, as I dead letter the messages, that reason code is now showing up on the other side. And the dead lettered messages can be read from the dead letter queue by either the sender or by some observer, which then goes and does some repair work on them. So you can go and effectively reject the message by pushing it into the dead letter queue. Getting it from the dead letter queue is something you can go on the queue client. You can go and format the dead letter path. So for, let's say, the queue test. And so now I can go and have a queue client, a dead letter queue client that I create as a queue client.create using that, using that path. And if I, now I can go and use that client just like a normal client and go and receive from that. And that's where I get the messages out that got dead lettered either by expiring, TTL, as I said, or because they were delivered too often, or they were dead lettered because the application is rejecting them in the same way that I just did. If you have an application internal reason to reject the message, so you have an exception that has been thrown, you can go and instead of just letting the message lock expire, you can be nice and you can go and abandon it. Abandon means that you don't want that message because it caused something bad. It will be redelivered to you effectively immediately, either to you or to a parallel receiver. With, if you say abandon, otherwise, if you just let that expire, then it's going to be redelivered as the lock expire. And then another feature that we have here is defer. And defer allows you to take a message and put it on the side. There's another side queue, a deferral queue. And the deferral queue allows you to put a message on the side that you currently can't process because, for instance, it came out of order. So you can put that back into the queue. The queue, it will not be delivered unless you specifically ask for it. So what you'll do here is defer will do that work. It will send the message back, and then you can ask for that particular message back by receiving with a sequence number. So you can effectively go and supply a sequence number. So we're going to go and get the sequence number here. Supply this. We're going to make a variable in a moment, and that I can get from the message. The message has a sequence number. That's its internal identifier effectively. And so I'm going to set this like this. Sequence number is that. So I can go and now defer the message, and then sometime later in the future, I can go and receive that message. It's an advanced feature. What you typically use this for is if you have some kind of state machine or some kind of workflow, and you get a message, but that message shows up early, you will go and defer the message, write down that sequence number in your state, and then when you're ready to process that message, you will go and grab that using the sequence number that you wrote down in your state, which might be sometime further in the future, sometimes hours or even days later. So those are the additional options that you have on the messages themselves as they relate to handling the queue. You can go and obviously also get a lot of information from the message. For instance, when it expires, now we're calculating this out of the time out of the time to live into an absolute timestamp. You can also learn when that message was enqueued. So the broker, our service, is playing a judge on time here. So you can use that kind of as a timestamp to determine timely order of arrival if you wanted that. Or if it actually matters, sometimes it matters in terms of deadlines, when the work was actually submitted into the system, not necessarily when that work was processed in the system. So if you have a deadline where data needs to be submitted by a certain point in time, you can use the enqueue time to see kind of as a proof point when the data actually arrived at the boundary of your system, if you will. So we're going to go and restore this into what we wanted it to be, into complete. And that was a very brief overview over the capabilities of the basic interactions with the queue, sending data, receiving data, and then some interactions you can have with a message as they're relating to the queue. If you're doing the receive mode, receive and delete, a number of those interactions don't matter anymore. Effectively, you can still do complete, but it will be a no-op operation. It will not actually call back to the broker because the messages are immediately deleted as you receive them. That mode is much faster, but it also has the drawback of being not as reliable. So you typically, for most, certainly business applications, you want to use the peak lock mode and then use complete to confirm that you've received the message. So much for an introduction, basic tour through the basics of queues, and back to the studio. So that was our walkthrough through the queuing aspect of Service Bus. Of course, very basic. And in future episodes, I'm going to go and talk about details of the programming model, or I will drill into individual features. I will also talk about the async programming model, which we prefer, will actually yield much better performance, both in the built-in programming model with begin and end, and then also show you how to wrap that for the task-based programming model that allows you to use async and await, which is a much better option. The other episode, which is going to be posted also today, is about topics, and I would recommend that you watch that too.